Recently, scientists have made an astonishing discovery in the cosmos: structures of colossal size, exceeding by more than 100 times the magnitude of our own galaxy, the Milky Way. This discovery has left experts in awe of their immensity. These structures completely challenge our understanding of the universe and fundamentally change what astronomers thought they knew until now. Trying to comprehend their magnitude is overwhelming and challenging, but before we delve deeper, why not give the video a like and leave a comment? Now, let's focus on the Boots superclusters. These superclusters are famous for their proximity to the Boots void, one of the most remarkable voids in the cosmos, discovered in 1981. Located about 700 million light-years from us, this void has a diameter of approximately 300 million light-years. Within the Boots are two superclusters, both approximately 1 billion light-years from Earth. The first is about 830 million light-years away, while the second is behind it at a similar distance. Although a comprehensive study of these superclusters has not yet been conducted, they are known to be considerably larger than the Virgo supercluster. The Boots void was discovered by Robert Kitzner, August Ulmer J., and Paul Stephen Shakeman in 1981. Subsequently, several studies were conducted to better understand it. A notable absence of galaxies was observed in certain areas, leading to further investigation. Over the following years, numerous galaxies were discovered within this void, increasing the interest of the astronomical community. Although several dozen galaxies have now been discovered within the Boots void, this number is still relatively low compared to what we were expecting to be found in a region of similar size in the universe. This suggests that there are still many galaxies to be discovered within this vast cosmic void. The Saraswati supercluster, recently discovered by researchers at the University Center for Astronomy and Astrophysicists, encompasses a vast space estimated to be about 600 million light-years across. This enormous structure harbors a combined mass equivalent to more than 20 trillion suns. Its discovery is especially noteworthy because astronomers have so far identified relatively few superclusters of this magnitude, which places Saraswati among a cosmic elite. This supercluster joins a few others known for their large size, such as the Sply concentration or the Gray Sloan wall in the nearby universe. But what makes Saraswati unique is its super far-off location, approximately 4 billion light-years away from us. This is the first time we have observed such a distant cluster. Even Shapley, which is one of the largest known, is 8 to 10 times closer. The researchers located Saraswati by examining data from the Sloan Digital Sky Survey. According to their estimates, the supercluster contains at least 43 groups and clusters of galaxies, including 400 galaxies in total. Most excitingly, its extreme distance means that the light we see from the supercluster has traveled enormous distances to reach us, showing us what the universe was when it was just 10 billion years old. Another example of a massive cosmic structure is the SFA2 Gray Wall, also known as the Cosmic Wall, discovered in 1989 by Mark Greener and John Utschka. This giant filament of galaxies is remarkable for its extraordinary size, ranging in size from 50 to 750 million light-years across. With a width of 200 million light-years and a thickness of about 16 million light-years, the SFA2 Gray Wall is home to 3 equally massive superclusters of galaxies, known as Hercules, Coma, and Leo. However, there is still no conclusive evidence for the full extent of this structure due to the so-called zone of invasion. This area of the universe, blocked by gas and dust from our own Milky Way galaxy, prevents astronomers from determining whether the wall continues beyond what they can currently observe. This phenomenon, known as a zone of invasion, constitutes of about 20% of the universe, which is hidden from our view due to interference caused by stars and stellar dust in our galaxy. At optical wavelengths, astronomers find it difficult to see through the dust block of our galaxy. However, they can circumvent this limitation by observations in X-ray and infrared light. According to the standard model of the evolution of the universe, structures like the Great Wall form a long filaments of dark matter that resemble a spider web. This dark matter, invisible but detected by its gravitational effects, it is believed to detect the large-scale structure of the universe. It gravitationally attracts visible matter, thus forming the long, thin walls of galactic superclusters. The Gallium supercluster, discovered in the 1980s, spans some 910 million light-years. To put it in perspective, the supercluster of Anarchy, like the Great Attractor, is about 520 million light-years across and has an enormous mass. However, the Gallium supercluster is even larger, being approximately 1.7 times more gigantic than the Anarchy supercluster. The supercluster hosts an impressive number of galaxy groups, giant galaxies and dwarf galaxies, being about 10 to the 29 times more massive than the Sun. The Pisces-Cetus supercluster complex, discovered in 1987, is another structure of great magnitude. It contains the local Virgo supercluster, where our own galaxy, the Milky Way, is located. This complex also hosts a large number of groups and clusters of galaxies, extending over 110 million light-years and with an estimated mass of 10 to the 18 solar masses. Pisces-Cetus is not the only structure containing the Virgo supercluster. The Annihilation supercluster also includes it. In short, the Pisces-Cetus complex represents one of the largest and most massive structures in the observable universe. According to Thule, who was its discoverer, the complex consists of 5 distinct parts, including the Pisces-Cetus supercluster, the Perseus-Pegasus chain containing the Perseus-Pisces supercluster, the Pegasus-Pisces chain, the Sculpture region containing the Sculpture supercluster, and the Hercules supercluster. In addition, the Lanichi supercluster, which contains our Virgo supercluster, as well as the Hydra Centaur supercluster. This set of structures was named after the richest superclusters, the Pisces edges. The Perseus-Pegasus filament is a huge filament-like structure that hosts the Perseus-Pisces supercluster. It extends approximately 1 billion light-years from Earth and is considered to be one of the largest known structures in the universe. It is located near the Pisces-Cetus supercluster complex, although some accounts attribute the discovery of this filament to Clyde W. Tumbley in 1936, during his research for trans-Saturnian planets, Walter Ever also reported parts of this cluster. The Great Boss Wall is a supercluster complex consisting of 2 main superclusters and several smaller ones. It was discovered in early 2016 using Baron Oscillation Spectroscopic Survey. Approximately 1 billion light-years across, and with a remarkable number of galaxies, some visible and some obscured, it has a total mass of about 10,000 times that of the Milky Way. Although its exact size has not yet been determined, this Great Wall is known to be extraordinarily large. Scientists mainly debate whether the supercluster complex is moving as a unit or whether it is gradually separating as the universe expands. According to Joshua, filaments play a crucial role on the large scales of the universe, forming a kind of cosmic web surrounding the voids, and these walls represent the thickest strands. Unlike other large-scale structures, Boss superclusters are much more densely populated with high stellar mass galaxies. This discovery provides astronomers with a valuable opportunity to better understand the large-scale structure of the cosmos. If you liked the video, remember to like and subscribe so you don't miss out on more content like this. Thank you so much for watching, and I'll be seeing you in the next video.